Hi guys, so I'm back at it again with another hacker rank. This one is called Pangrams. It's also in the 1 month prep kit. So the main idea behind this question, okay, to be honest, I don't really know yet. I have to read it again. Um, okay, a pangram is a string that contains every letter of the alphabet. Okay, got it. So let me try to do another speed run. Try to do it try to keep the video less than 5 minutes. Yeah. So the string has to be if the string has all the items inside, we consider that a pangram. So it's like A to Z all the way. But the thing is, we might sometimes have A as a small letter lowercase a, and sometimes we might have a uppercase A as well. And they mentioned to us that the length of the character is 1,000. So the reason why I'm doing so fast is because we don't have a lot of time to read through everything in an actual test case, I mean, actual question lead code as well. Sometimes it's just better to start coding, writing out something and seeing if it sticks. Yeah, see what sticks. Anyways, in this case, there are a few things that we need to consider. One is that there might be lowercase and uppercase letters, and there will also be a possibility of a space. So what I'm going to do is I'm going to keep count of I'm trying to do it in the most efficient manner, like in terms of time complexity. So I ideally just want to scroll through the entire thing once and only once. So to do that, I'm going to first create a empty variable just to keep count of things. Oh no, I pressed the wrong button in my mouse. So keep count of something, and for I in range S. The hacker rank is lagging once again. Oh no, sorry, not range S. Hacker rank in S. Sorry, for I in S. So for I in S, let's say, firstly, I'll lower all of them. I don't want to lower all of them from the get-go because lowering the string is time complexity of O(n). I don't want it to be like an n and n plus n. I just want it to run once. So when it's when it's going through the for loop, it'll just be O(n). And yeah, a is equal to I dot lower, and a, what I'm going to do is I'm going to have a set. Should I have a set? Yeah, I'll have a set. So the reason why I'm having a set is because a set operates on a time complexity of O(1) for all referencing operations. So what do I mean by that? If, let's say, if a in set it dot add a, else we just ignore it. Like if it is not inside a, we just, sorry, if it is in a, okay, so if the alphabet that we're looking at right now is in the set, we don't add it. So continue. Else we add it to the set it add a. So what's going to happen is it'll first lowercase all the alphabets that are coming in. Once it's lowered, it'll check if it's already present in the set it. If it is present, it'll just continue because we don't want to keep adding the same thing. But even if we do, not a big issue because a set doesn't accept duplicate values. So I'm just going to do this. So what I'm going to do is when I'm adding something, I'll make the count to be plus equals 1. So in the end, okay, we also need to take care of one more condition, one more case whereby the string value is a space. If it is a space, I just want to ignore it. So if a inserted or, sorry, or a equal sign, a space. So if it is either one of these conditions, it will just continue, and that means it will just go to the next item in the string. Else it will do this thing, set it dot add a, and it'll count to +1. So the count is actually unnecessary. We can just do a length in retrospect. I'm thinking about it now, but let's just see if this makes sense to you guys now. So what I'm going to do is, after running the for loop, I've passed through all the items inside the string, and I can just run a simple if else condition to see if count equal sign 26, because the 26 alphabets in the alphabets. If count is equal to 26, return panagram. Pangram, sorry. Else. Oh, I hate these. Return not pangram. So on first glance, it seems like that is it for this question. Let me just try to run this. Okay, it passes all the test cases. Our program works perfectly. But this is for those who want to improve the solution. So while yes, this works, sometimes you might run into a case whereby we might reach all the ABCD, A to Z, even before it runs through the whole series. So this is a special case whereby we can just keep a constant check over here. If count is equal sign 26, we terminate the program earlier. So we just need to return pangram earlier. So if the count is equal to 26, it'll return to pangram. It'll return pangram earlier. The reason why I'm able to do this is because we're only adding +1 if it is not a spacebar and if it's not already in the setted. I'm sorry for calling it setted. It's kind of annoying to my for me saying it out itself. But yeah, what's happening is, since we might be able to find all 26 characters, maybe like somewhere around here, like halfway through the thing, we notice that we already have all 26. And if the string is like 1,000 characters long, this would be more than sufficient. As in, this would be a smart way of terminating the program earliest, because that's the condition that they want. There's no failing condition whereby if there are more things, then there's no such thing in this question. So we can find the early termination code over here and just run this. So let me just try this out, see if it works. Yep, it still works in this case, and it still passes all test cases. And this would effectively be faster than the previous solution that I presented to you guys. So that's it for pangrams. Hope you guys enjoyed the video and learned something. I definitely had fun doing this, and I look forward to seeing you guys in the next video. Bye.